Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Well, welcome everyone to Did You Know? The ESCO HVAC Show. So we've spent a lot of time talking about how we're making changes in our industries, all the way from regulations to changes in equipment, and now, after spending last week looking at how changes are coming to our equipment from the manufacturers, it's a good opportunity to start talking about how to properly protect our equipment. So this week we're going to spend a little bit of time with Keith Clark from ICM Controls, and most of you probably recognize ICM from control boards. I know when I was a technician, ICM was on my van as a regular stocked item. Now, ICM has a lot of other components to the industry that not everyone is aware of that you're probably going to be looking at a little bit more as we start diving into new technologies. So today, let's talk a little bit about voltage protection and the importance that it's going to play with inverters, particularly as we move forward in the industry. If we look at surge protection, by definition, it's a spike of power on an appliance or device, and we use the surge protection to help protect that component. Well, how do we do that? Well, most of the components in our surge protection devices are built around a technology called metal oxide varistors. So what they are is they are a component within the circuit, and you've probably seen them and may not have recognized exactly what they are, but it is a device that is used in the electrical circuit to help detour high voltage, high inrush current scenarios on our electrical circuit. And we can use them in a couple of different ways. We can use them between line voltages, and we can use them between our lines and our earth or our common connection. They're in the circuit, but they're not a path of flow. So what we're doing is we have a high amount of resistance to flow so that our current is flowing through our lines, but when they are subjected to a high inrush of current, they open up and we move the current and we redirect it so that we can protect our actual components. Very important part of the system. If you've ever worked on a ECM blower motor and you've had the module off from the back of an ECM motor, you have recognized that component if you looked inside. So it's on a lot of different components. And from the Packard Academy, one of the statements that was made was a major cause of failure occurs when a blower is applied to an application with a static pressure above 0.8 inches of water gauge, water column. So we're noticing that we're having failures of these components, not just with high voltage applications, but with high temperature, high current applications from motors being overdriven. In the old days of ECM motors, before we had so much epoxy built into our ECM mods, we would actually replace these as a procedure. We don't do that as much anymore. We typically replace the entire module, but that is a component that is failing. And what they do is they will overheat as they're inrushing that current, and this is what they will typically look like. So when we start talking about adding surge protection to HVAC equipment, do you provide any types of add-on components? So if you're out there in the audience and you have any comments on that, we'd love to hear from you in the chat boxes, because not everyone looks at surge protection as being a component within HVAC, but it really is. And when we look at our power grid and when we look at how our current is flowing through our grid, we're starting to hear more terms like brownouts and blackouts. And we want you to understand what those are and how they affect our HVAC equipment. A brownout is caused by high electricity demand that is near or above a utility's production capability. So we're not able to produce the amount of flow that we need to, right? This is coming from direct energy. So when that occurs, the utility may reduce the flow of electricity to certain levels to help prevent a blackout. We all know what the blackout is, right? So that's a large-scale service interruption that can happen as a result of severe weather or equipment failure at power plants. So we have variations in our voltages, and not everyone is aware of how wide of a range that can be. If we look at our range of voltages, we typically will put it into two classes, range A and range B. So most people fall within our range A, which is our distance from our source of power. And we typically have a variance between plus and minus 5%. So a 120 volt system should be between 114 and 126. A 240 should be between 228 and 252. Until you get further down that grid and we start getting into range B, right? So when we're range B, we actually have allowances. Now this is coming from ANSI standard 84.1, which is where our services are designing their supply of power. We can go above by 5.8%, but as low as 8.3% below. So now as we get further away from our grid, it is acceptable to see voltages on 120 volt circuits from 110 to 127 and on 240 circuits from 220 all the way up to 253. Now, that's a pretty significant change on our perception of 120 and 240, right? Well, it can even get lower than that. So we now have to look at, okay, we can have a percentage of loss on our structure as well. And so we're going to call that utilization voltage, right out of ANSI 84.1. So with that, we're going to have an additional loss in our structure, as much as in those ranges that are further away from our voltage supply, as much as 13.3% below the rated, which means a 240 volt system could potentially have as low as 208 and as high as 252. So our voltages are going to play a role in the future when we start looking at ways to protect our equipment from things like brownout voltages. So with brownout voltages, we can actually see ranges as high as 10 to 25% away from the rated voltage, which means a 240 volt system could potentially be all the way down to 180 volts at a 25% load reduction on a brownout. Pretty significant, right? Well, with that brownout, we look at that as if it can be recovered within 1 second, it's just a sag. It's not an incident. If that voltage gets below 80 volts AC to ground, then we're going to go into a blackout scenario. And that's when we're actually going to shut our power off. But it's those brownout conditions that are really scary when we start looking at inverter technology. If we look at the nameplate, our OEM nameplate, we're going to see the rated voltage for our pieces of equipment. Previously, you wouldn't see as much of this on our single and two-stage equipment, but with inverters, they definitely have voltage ranges. So when we start talking about voltage ranges, what can be the consequences of over voltage and under voltage? Well, I went ahead and picked on 3 different manufacturers here. If you're installing many inverters, you're going to probably recognize some of these. These are 3 primary brands. And with our inverter technology, we tend to have error codes, fault codes, that recognize things like under voltage and over voltage. So we have the potential for error and fault codes based on the voltage being supplied to our house. I've seen this many times as a TSA, where at the end of power grids, I would have new inverter technology that would randomly throw in some fault codes. Most of the time, they're pretty recognizable. This particular brand is just an error code 25 for a AC low or high voltage. This one over here is a couple flashes with a P1 code showing that's a voltage protection. Here is one that is really interesting when we look at fault codes. If any of you are familiar with this particular service manual, blower fault codes are really common on ECM motors that have high static pressure, right? It's just a very common fault when we're installed out of parameters. Well, this particular B6 fault code is the motor itself recognizing that there is a variation in voltage, either high or low, or that ambient condition on the motor. So the fault code is in relation to the voltage that is being applied on the circuit. So to do that, we have different devices on the market to focus in on the problems that we have with poor power. One is going to be a surge protector, which we're going to dive into a little bit deeper here in a minute with Keith. And the surge protector is going to do that same function, either being applied in the electrical panel or at the outdoor unit, being as a type 1 or type 2 installation to help shed that excessive voltage when we have high surges. But then we have other components like the ICM 493, which is my preference of protection devices for inverter controls. This happens to be one that I've installed myself. And as you can see, they're not a whole lot larger than our traditional disconnect, but now it gives us the ability to control the voltage being applied to that piece of equipment and actually take it out of the circuit if our voltage gets out of the parameters. Really, really cool component that Keith is going to dive into and give us a little bit more details on that. So Keith, thank you so much for joining us today, and welcome. Love to hear a little bit more about the products.
Yeah, appreciate being here, and thank you all for taking some time out to tune in on this and learn something about these products. But do you answer questions along the way, or?
Yeah, so we've had a couple come through. One, Michael says that he always adds surge protection on quotes on inverter equipment. And that's really what we're here to discuss, is a lot of people don't understand that additional component on your inverters is really an extra fail-safe device. So really important. I'll let you know if we have some others that come through.
Yep, great idea. And Bill says it's a good idea to add to any mechanical equipment, and that is in fact true. It's cheap insurance policy, and we'll get into some of that here. Take a look at some of these products, but we'll start out. So I'm the national sales manager for the HVAC aftermarket with ICM Controls, and a great company. We make great products, all manufactured right there in a house in Syracuse, New York. And so one of the things that you were discussing is brownouts and blackouts. Surge protection devices are great for spikes and surges, but brownouts are equally dangerous. And so the only way to really protect from that is with a line monitor, and they are different animals. So we'll get into that a little bit. But first, we'll just take a look at why you need a line monitor. And this is probably old hat for a lot of you guys, but the power plant generates electricity, and then they send that over to a step-up transformer so the voltage can travel long distances. And then the transmission lines, these big power lines that you see out there, carry to the substations. Substations will step that power down to industrial facilities that operate generally on the 600 volts. Then substations will step it down again and send it to commercial facilities, a lot of the types of businesses that we call on in the HVAC and our market, and they bump that down to 460, 480 volt. And then substations again step that down to 230 volt, which supplies our homes. And any disruption in that chain can cause surges, spikes, dips, brownouts that can damage equipment.
A lot of potential variations by the time it gets down to that residential end user.
Oh, so many things that can happen. Lightning strikes, a car hitting a power pole. It's endless.
Yeah, windmill speed variations.
You bet. And even in some commercial facilities, they may have equipment operating that needs a lot of amp draw, and when that equipment shuts off, it can surge back onto the line. So we do have single-phase line monitors like this ICM 492. Basically, line monitors provide protection from voltage swings over, under, that can damage equipment. And so they have adjustable settings. So you set your parameters for over, under. Some of those values that we were just talking about, you can set the monitor up, and if the values are outside the parameters that you set, in this case, what we do, these will break the Y circuit. So if there's, a call for cooling, this unit is able to then break the Y circuit, not allow the contactor to pull in, cutting power to the unit. And you can calibrate these things to a true RMS, hook up a meter, and then calibrate it to that so that you're within a really good accurate range. And like I say, if the voltage is outside the range, then it doesn't allow the contactor to pull in.
Now, Keith, I
So
do have one question on that. So
yeah,
I've had technicians ask that before. Is it recommended that we set the parameters, the low voltage and the high voltage, based on the minimum and maximum voltages for the piece of outdoor equipment?
for yes, the equipment values, and like you say, on all the inverter stuff nowadays, it's all stated very plainly on there. You can find it in the manuals and things for other equipment as well. But yeah,
Exactly.
it's a good idea to set it at the values that are recommended by the manufacturer. But it can protect against rapid short cycling as well.
Mm-hmm.
Have some adjustable timers in there, adjustable voltage set point, the over and under adjustable anti-short cycle time delay, and then adjustable response time. So the time that fault must exist before it'll shut it down. Control mode, there's some relay contacts in there that close when the voltage conditions are good. 5-fault memory, that can be very helpful as well.
Oh, yeah.
If you're experiencing faults, the power companies are not usually super cooperative, and so it gives you a little bit more leverage with them to show them right there what those faults have been. Universal line voltage input 80 to 300, and various features. It's a nice little control. But basically what we're doing with that is so on a call for cooling, 24-volt signal is relayed to the contractor coil, and then that allows the voltage to make across line and load, and the contacts pull in and power is supplied to the unit. So by just breaking that Y call on the contactor, we're able to prevent that contactor from pulling in to protect the equipment.
Really
So,
good add-on component for a legacy system.
Absolutely, yeah, and very easy to install, super easy hookup. Basically, this is showing the wiring for that. You just take the I'm looking
Or incoming power.
Yeah, you take your incoming power, from
So
the
L1,
disconnect.
L2,
L1
or hot
and L2.
side.
Yep, piggyback on those, take those to L1 and L2 on the controller, and then the hot side of the coil, you take that wire and put that on the normally open contact here, and then put a jumper between common and the coil, and now you're all set, and you can go in and adjust the parameters. We have installation videos and all the support materials that are necessary out on the website. So a lot of really good support videos that are available out there if you want to dig deeper into some of these.
Yeah, you guys have some very good resources.
Yep, absolutely. And, very simple to hook up, and very inexpensive compared to any problems that you could incur not having the device in place. We also have these available in a 3-phase version. ICM 450, this is a very popular product.
Very, very common part.
Yep. And so same thing, monitors incoming voltage. In this case, we look for over, under, imbalance, phase loss, phase reversal, and it has a lot of the same features, programmable features that the 492 has in there. Backlit display, true RMS voltage on these models, and takes it safely offline when the power abnormalities, when it's outside the ranges or any abnormalities that exist. So, there's a lot of areas that do have some dirty power. They're
especially their 3-phase power. Yeah, Donald just now put a heart and a comment for that ICM 450. So obviously a fan of that 450 in our 3-phase commercial and industrial sectors. Thanks, Donald.
Yeah, we appreciate that, and we're going to get into why it's important to add a surge device with these as well.
Sure.
Because line monitors are great, but they really are not. A surge protector is not a line monitor, and a line monitor is not a surge protector.
Exactly.
A surge is such a rapid event that it can sneak past that line monitor. And I've had people say, that the numbers went wonky on the screen, or they had to reset the system, to bring it back online. And that's due to those rapid surges.
Sure.
So a line monitor needs to see a little more prolonged event before it's going to take it offline. So not designed to protect against lightning strikes. These are available, internally they have English or Spanish menu options, which has been really
Oh,
really
that's
good.
nice. I didn't realize it had that.
Yep. And is I don't want to miss some of my notes on here. Is there a way, I see the questions off to the side. Is there a way for me to switch that easily?
The questions? I'm not
Yeah,
sure on that one.
to see my notes.
Yeah, probably not.
Okay. So we will wing it through. I'm going to miss some really important points that I wanted to share with you guys potentially here, but and then there is the ICM 450 Plus. This is a great product as well. This is just an upgraded version, an alternate version, because some people want, well, it has the real-time clock for a date and time stamp. And
Sure.
that is very helpful also with power companies, because maybe that event is happening at peak time every day. Maybe there's a certain time of the day that there's an event happening that's causing that surge, and then, or that, that condition, and it gives you a lot of leverage then with power companies to come in and fix those problems. Maybe they have a bad transformer, some other issue.
Sure.
And then we also have Modbus 485 communication on this. Listen to
nice feature.
Yep. Very nice. And so looking at imbalance, so over under voltage obviously can be a big problem.
Sure.
And can damage equipment. Unbalanced is equally bad. So if you have unbalanced three-phase voltage, this chart is really good. Percentage voltage imbalance, just on a 2% voltage imbalance, 8% increase in motor winding temperature.
It's pretty significant. Very
significant. And as you can see, as it moves up the row here, 5% out. And you were talking earlier that 5% is kind of the base standard, right? And now you're talking.
Think about all that additional temperature just by 5%.
Yeah, 50%.
Yeah.
So it can be very critical, and line monitors can help you with that. Very easy to install. Protects both line side and load side. And one of the things that's significant about that, even at our ICM facility, we had an issue years ago where a spider got in the contacts of the contactor. And when it made contact, it fried, the compressor. So that was a pretty expensive lesson. And that's why load side protection was added to our line monitors.
Okay, so it's feeding from both sides of the control.
Yeah.
Huh. Okay, I guess I hadn't realized that. And that's on the 450 Plus?
450 and the 450 Plus.
Yeah, okay. Really cool.
So line monitor is not a surge device, and a surge device is not a line monitor.
Right.
These are really necessary to protect your equipment from transient spikes, surges, dips due to faulty power, and it's happening more and more. I saw your Tesla or whatever on the charger, and so much power, so much pressure on the power grids lately, and a lot of our stuff is old and antiquated. We oftentimes go in and help other countries rebuild after destruction and
natural disasters and
and they have more modern power grids than we do in a lot of cases. So
wow, yeah, that's pretty crazy.
We've got some catching up to do, but safety first. Safety is always primary issue. Primary concern. So please follow all instructions, local codes, safety protocols whenever installing electrical devices. Electricity is potentially dangerous, potentially deadly. And so you should really use caution and common sense when messing around with electrical equipment. So why you need surge protection. Back to this slide here. As we see the way power travels and all the different things that can occur, they could have a problem at the industrial facility, that sends bad power downstream. And same thing in the commercial substation. They could have, things blow up, burn up, cars crash into it, whatever. And it can cause problems down the line. So things like lightning strikes, it creates such a rapid, violent event, that it can really wreak havoc on systems
on an
and
entire network.
And even the phase monitors, the line monitors themselves can be damaged by these surges. So surge protection devices are very helpful, very necessary. And this is kind of interesting, to think about. These are much larger scale, obviously.
Mm-hmm. Same principle.
Same principle. And we see these all over town, right?
Yeah.
Transformer. And these devices here are surge devices. That's what these are. They're surge suppression devices using MOVs. And so all this, TMOV and a TFMOV and all that. Metal oxide varistor. Varistor is a variable resistor. So thermally protected, thermally fused metal oxide variable resistor. That's the best technology that's out. It's the most modern, most up-to-date technology. And so they use this, on the power poles and stuff.
Sure.
And at the heart of all arresters is this metal oxide variable resistor. And the MOV disc in these large units is a semiconductor that is sensitive to voltage. So at normal voltage, the MOV disc is an insulator and will not conduct current. But at higher voltages caused by lightning and other events, it becomes a conductor. And they're self-sacrificing. So these things take the hit and they get burned up, they get used up. One thing to consider, homeowners already use surge protection devices. We all use them.
Think about that on how inexpensive of devices we invest into surge protectors for.
Yeah, exactly. And, we all have these in our house, though, and we protect our TVs, our computers, gaming equipment, music equipment, whatever larger type, more expensive equipment we have.
Right.
We always try to put a surge protector on there. Why wouldn't we protect the most expensive equipment we have?
That's exactly right. That's the conversation to have. If we're spending $10,000, $15,000, $20,000 on a inverter driven HVAC system, and we're talking about a very minimal investment for surge protection and voltage monitoring. It's something that is overlooked very much in the industry. And that's what we're hoping to do, is to educate people a little bit better on being the responsible contractor looking at helping add some insurance to that homeowner on their investment.
Right. Well said. And so these devices, these all employ those same type of components. Obviously, unlike the power poles and large electrical substations and things like that, they're much smaller devices. So we're using things for electronics manufacturing that are much smaller. And I've got some examples of that. We already saw some earlier on. But the way that it works is like our ICM 517, for example, it contains 2 banks of TMOVs. And when they're heated up due to voltage spike or surge, they'll open and allow the device to fail safely. These newer variety are encased. The way they're constructed, they're fire resistant, fireproof, easier to get UL listings on and stuff because of the nature of that TMOV. You've seen some surge devices, fire and mayhem, right? You've seen stuff blow up and burn up and all that. And those are typically older model where they weren't maybe using the latest TMOVs and things. I remember seeing some of those devices that had sand inside of them, and that was to suppress flames and and everything else. These are far superior to that. Fantastic device, but the TMOV is self-sacrificing. So it's taking the hit, it's absorbing that voltage spike, and it's dissipating it through these zinc oxide grains that are inside. It allows that surge to be absorbed in there.
Oh, okay.
And so the number of TMOVs that are taken out, during a particular event it's a big question mark.
Depends based on how much of the inrush.
Yeah, depends on how big the spike is, and
exactly.
Lightning strike, can be enormous, can take everything out.
Right.
But it will continue to offer protection as long as it can. So it's self-sacrificing. One event is not going to take out a TMOV necessarily.
If it has multiple banks.
Well, and a single TMOV can take a number of hits depending on the size of the hit.
Okay,
If
so
it's
as long
still,
as it hasn't dissipated the heat and, ruined the integrity of the construction.
right, that TMOV will still offer protection as long as it can. And
Sure.
then with a bank of them in there, then it moves to the next one. And we have a series of lights on there and stuff that'll tell you how much protection is left if it's
Gotcha.
still offering protection. So
Not a one and done deal necessarily
not a
then.
one and done, right? Exactly. Um, So, thermally protected metal oxide variable resistor, right? So they come in different shapes and sizes. What you'll see in our components are usually these kind of little square blocks. Some devices you will see, and it says MOV right on the face of that.
Sure.
Different styles, different shapes, different sizes. What you're typically going to see in a power strip is probably something like this. Um,
Yeah.
they still offer
Right.
protection. There's nothing wrong with them. They work, but they do have to be replaced. And usually with a power strip at home, you can't tell if it's still providing protection or not. With a surge device, the desire is to offer protection, but not take the equipment or devices offline if it's
I
burned
gotcha.
up. It's just not offering protection
Sure.
anymore.
It's not like a
So,
circuit breaker or a
uh,
shunt trip where, it's completely removing power from the load.
right. It's going to let it continue to operate. And that's where the danger comes in with your power strips at
Sure. I
home and
never
stuff.
really thought about
I
that.
actually,
Yeah.
yeah, I actually had a situation. A neighbor across the street got hit by lightning, and I had several TVs in the house. One of the TVs was not on a power strip, and it was damaged. All the other ones were fine, but that one got burned
Wow.
up.
Yeah. I've never thought about that. Most of
So,
those residential protection devices, at least the older ones, don't have any indicator if you have actually lost function of your MOV.
right.
Okay.
So surge protection devices, they come in different shapes and
Mm-hmm.
sizes, and they absorb those spikes and surges caused by lightning strikes, other power disturbances, and then safely dissipate that energy. So, like I said, self-sacrificing, wired in parallel. Um, and I know there was a note uh, on here, but I will move on. So there's different types, type 1, type 2. The type 1 is approved for whole home or whole panel applications. It protects every breaker on the panel. A type 1 can always be used as a type 2 for a single breaker or a single appliance or piece of equipment.
If it has an electrical disconnect device that kills power to the component that you're connecting it to, like a disconnect.
Right, right. Or a breaker on a panel.
Yeah. Single component.
Yeah, single component.
Just nice to distinguish the differences between field installed and electrician installed.
Yeah. Type 2, approved for a single breaker or appliance such as an HVAC condenser. That's where we see the 517 installed most, and actually the
Sure.
518 as well.
I can see that.
Yeah, because a type 1 really it needs to be installed by an electrician, by a licensed electrician, and I'll touch on that. I've got a slide on that.
Okay.
So the 517, it's UL listed, type 2 device, metal NEMA 3R rated enclosure. So you see
Nice.
the cover is removable on that. And it's suitable for outdoor applications. Rain's not going to hurt it, that kind of thing.
Sure.
But it is not waterproof like the NEMA 4s.
Right.
Our other devices are NEMA 4. But it keeps costs down, and really for what our guys are using it for, most people are putting this on an outdoor condenser.
Yeah, I can see that.
It offers great protection, 100,000 amp protection, and it's real simple to install, and it's very, very robust design, low cost, American made, all that. What's inside the 517 are 2 banks of 5 TMOVs. So this thing will take some punishment, and the lights will light up and let you know if it's still providing protection.
Okay.
100,000 amps. And again, this is what it's utilizing are these TMOVs inside.
Sure.
The way to wire this up, so you can wire it onto a panel, and we're seeing this here on the left. This is wiring into a single breaker. So if you installed that mini split, or you want to put one on your refrigerator or your TV or some other any breaker that you want to put this thing on. You can install that. This is a 230 volt because we're using 2 black wires, so that's a double, tap breaker, and then ground to the bus bar. Very simple, and then the neutral to the neutral bus bar. On this, we're installing this outside. We're just going to piggyback onto L1 and L2 incoming power, and then ground it, and you're good to go. So now that's providing protection for that piece of equipment outside as opposed to at the breaker panel.
Yeah, pretty easy install.
Pretty easy. ICM 518. So this is type 1, and this is fully watertight NEMA 4 enclosure. Can be used as a type 2. Any type 1 can be used as type 2 as well.
Sure.
Split phase, it says split phase right on the face, and that is just simply a standard house panel. So you have 2 115 volt bus bars so that you can, put 115 volt power to power your TVs and your refrigerator and your, anything you plug into the wall. But then also you can use a breaker that taps both of those bus bars and then gives you your 230 volt power. So split phase just means there's two separate bus bars.
Be a good candidate for a generator, wouldn't it?
Absolutely.
Oh yeah, I could definitely see that. Either single or twin circuit capabilities. Yeah, definitely.
Yeah, generator would be great, and you can run mini splits off generators, and so in a pinch, like if the power goes out and you have that blackout outside, at least you can still run your AC, right?
Yeah, exactly. That's a nice little piece. I wasn't familiar with that 518, but I'm really starting to like that.
It's a great little product, and so 50 or 60 hertz LED indicators on there, and there is a limited lifetime thing that is with most surge protection devices. They offer that, and it's basically as long as it's within the parameters of the unit function. It's not like guaranteed for life because it's going to be taking those hits and everything, but any defects in manufacturing or any kind of thing like that, there's some extra protections there for you.
Nice.
Should we look if there's any questions?
Yeah, I think we're good right now. Just a couple notes on the PowerPoint of using the Alt F5 to bring in the notes, but then it would also display it onto our screen as well.
Oh yeah, I don't want to do that.
Right.
Okay.
But I appreciate that, Paul. Thanks for catching that.
Thank you very much. Okay. And what's inside the ICM 518? So this, rather than having 2 banks of 5 smaller TMOVs, this incorporates 2 very large TMOVs. This offers 200,000 amps of protection versus the 100,000 in the 517.
And I think that little video is on the 518, isn't it?
It is, yeah.
Yeah. Let me pull it up real quick.
The ICM 518 is ICM Control's newest UL-listed Type 1 and 2 surge protective device for a 240 VAC split-phase configuration, designed for usage in HVAC-R, appliance, electrical, and pool and spa applications. When a surge occurs, the ICM 518 absorbs the surge up to the specified limitations of the device. ICM has incorporated superior thermally protected metal oxide varistor technology, which allows for safe disabling of the surge elements when the thermal limits of the device are exceeded. A status light identifies proper operational status when illuminated. The ICM 518 can be installed as a Type 1 or Type 2 device and is housed in a NEMA Type 4X watertight enclosure for both indoor and outdoor applications. ICM 518 is proudly manufactured in the USA in a state-of-the-art ISO-certified facility in upstate New York. Visit the ICM Controls website to find a distributor near you.
Man, yeah. Keith, I'm kind of liking that.
Yeah, it's an impressive place. If you're ever up in that neck of the woods, anyone that is up in that neck of the woods in Syracuse, we'd be happy to take you on a tour through the facility. It's really fascinating. I mean, we take the raw board material, we drill it, plate it, etch it, component insertions all automated, wave soldering, weave and injection mold our own plastics. And,
nice.
All of our products are 100% tested there in the facility before they go out the door. So.
I'm feeling a road trip over to the ICM.
So this is kind of interesting. I was looking for some information for this presentation, and as I watched a couple of videos, I found something here. So understanding how to install a surge. This installation was done by a non-electrician as a whole home protection device. And based on what we've been talking about so far, does anybody see anything wrong with this installation? Anything that jumps out at you? And one of the things I should probably do, although this covers, like, this is one of the things that should be evident here, this breaker, and then on the device itself, it says type 2.
Right. So it's not an actual type 1 whole house device.
You need a type 1, and one of the major problems with that is if you install this as a whole home device and there's ever any kind of a fire, it doesn't even matter why it happened, that the type 2 device being in there is not code, and an insurance company could deny a homeowner a claim
Sure.
on a fire in their home.
Yeah.
And then the next person they're going to come after is the person that
installed it. Yeah, absolutely.
So you definitely need to be careful about that. Now, the funny thing, and you mentioned this when we were talking about it, is the only thing this is protecting is that single breaker that they
single
installed.
circuit.
Yeah, and what the person on this video mentioned is that, well, even though it's at the bottom of the panel, it's a shorter distance to the device than to the refrigerator, for example, and so it'll protect it. Well, electricity travels pretty quickly on those lines, and so unless it's mounted up here
on the bus,
and so understanding how to install this correctly, and this is why I say an electrician needs to install this. Our HVAC people are not going to. They don't have the means to shut down main power that's feeding this main breaker. There's still 115 volts here on each of these legs. When you shut this breaker off, it only stops feeding the things that are below it. There's still 115 volts on each of those legs. And you don't want to get in there touching that, or, it can be very dangerous. So,
thanks for pointing that out. That's a big deal.
Yeah. But it opens you up to liability if you try and install that type 2 as a whole home. Only UL listed type 1 is approved for that whole home application. Insurance companies can deny a homeowner, and that'd be a really, really horrible thing. But type 1 devices need to be installed by a licensed electrician, because like you say, they're the only ones that can cut this power and be able to put that thing in the correct way. So this is where it would go in. Real simple, black leg on each 115, and then the neutral to the bus bar. Wiring this 518, so they're showing, and like I say, this on the left is for the whole home. That's probably not something that we're going to mess with.
No. Should be an certified licensed electrician installation for that type 1.
Absolutely. So, we're going to put it on a single breaker or on that disconnect outside for the piece of equipment. So what if we do have an HVACR that can do the installation? If they're licensed for a licensed electrician, then they should be able to do that.
Okay.
I'm looking at questions.
Sure. One of the questions came through, which may have to be covered a little bit later in a regroup, was, would the surge protectors meet the new NEC code requirements in regards to GFCI, especially in the Texas allocation?
Yeah, we'll have to look at that.
Exactly. Okay.
All right. Thank you for the questions too. Keep those coming.
Yeah.
So 3-phase surge protection, we offer several different devices for this. And basically it's the 530, 531, 532, 533. The difference is 530 is 233 phase. The 531 is 483 phase. And then 532 is 600 volts, and 533 is the high leg or the wild leg.
Right.
I haven't seen that myself, really, the wild leg thing.
I've only ran into one of those transformers my entire career, and that was at a 100-year-old manufacturing facility.
Yeah, and I think most of those are getting changed out. You know,
Yeah.
they have to upgrade and all that kind of stuff. And
Exactly.
we have it, but it's
interesting to know that you have one there. My first introduction to a 3-phase line monitor was on that high leg transformer, and it would not operate properly because of its voltage readings to ground. So it was a very interesting scenario, but that's the only one I've ever had to encounter.
Yeah, it's a wild thing, and like I say, it's an anomaly, but it is there if you need it.
Yeah.
And then the 532, the 600 volt, not something we run into a ton. I think for HVAC and R, we're going to see mostly the 230 3-phase and the 463 phase.
Correct.
So, but they're all the same as the 518 NEMA Type 4 weatherproof enclosure, waterproof enclosure.
Fantastic refrigeration component.
Yep. And, does all the same stuff, protects 3-phase equipment in the same fashion that the single-phase models do. And made in the USA, very rugged, UL listed, all that stuff. So, and there are diagnostic lights on there that'll tell you if the unit is still providing protection. The wiring for it, don't know we need to belabor that too much, but this is for the Delta configuration, and then this is for the Y configuration, and they have both a whole panel or an individual breaker wiring instructions in that. Again, if you go to ICM Controls, you can find anything you need on this.
Sure.
So the ICM 493. So now
my favorite.
This is the one you're excited about.
Yeah.
But this is a combination device. So this is just really brilliant technology. Inverter systems are different than conventional systems, and in every way. So they're taking the incoming AC power, they're converting it to DC, and pulsing the compressor and pulsing the motors to get them started. Everything's soft start. It's really awesome. And I hate to say it, but the Asians are beating us at air conditioning technology.
Oh, significantly. And that was one of the reasons we wanted to bring this in this week. So when we were talking to Rheem last week, looking at their new product lineups, we're talking about moving to a significant amount of their new equipment is going to be inverter technology. It's not like it's a small portion. We're talking very, very significantly high amount of equipment. And that really is the next stage of technicians and the HVAC industry here in the United States is the development of inverter, and particularly in the residential, but in other sectors as well. So they're here to stay for sure. So it's a matter of educating people on how to properly protect and give some insurance on these installations.
Yep. And they can be a little more sensitive in some ways. It's still awesome stuff though. So 493, what this is, line voltage monitoring with built-in surge protection. And it's single phase. And we will look at some of the insides of this thing, but it's single phase line voltage monitor, provides the best of both worlds, really. It's ideal for mini split, in inverter systems. And there's a 40 amp version is the standard 493, and then a 493-60A comes with a 60 amp contactor.
60 amp control. Yep.
Field programmable, lets you set min and max parameters, just like our line monitors. Has a fight fault memory. And then digital's display will tell you exactly how many TMOVs you have left. So there's a bank of 5 in there, and it'll tell you 4 left, 3 left, 2 left.
And it's something to be paying attention to. So one of the reasons that I wanted to discuss that particular function, we have a lot of contractors, technicians that are joining, and if they see this component and they have never worked with it before, it's a good idea to take a look at the display just to verify what the state of the component is, because it technically becomes a serviceable component if we've had MOV failures.
That's right. And so we do have a replaceable board in there too, which is very nice. So the 60 amp version, same basic thing, just with that 60 amp contactor, a a little larger unit. So the combination devices, the front panel in there, it comes in an NEMA enclosure, NEMA 3 enclosure, and the front panel folds down. There's a couple of screws in the bottom, and it'll hinge down off of that, and the board is easily replaceable. There's an onboard transformer and an onboard contactor that actually are breaking line voltage, because with an inverter system, if you don't have that contactor in there, and you don't, you've got line voltage going right to the unit, and then all the rest of that stuff happens internally to the unit. You can void warranty if you get in there messing around. There's a whole host of problems that can happen.
Sure.
So this is an external device that can actually cut line voltage to that unit if the power is outside your parameters, and will also absorb those spikes. So this is the bank of TMOVs over here. Got your contactor back here and your transformer. And basically we'll just open the transformer. We'll open the contactor.
Open the contactor.
Yeah, if the voltage is outside your parameters.
Exactly.
And so this is kind of what the panel looks like from the back. And you see the wiring, it's very simple. If you went in to change this board, you got 4 wires to unhook from that. And I mean, you almost can't mess it up.
No, 2 for high voltage, 2 for low voltage. I mean, that's really about it.
That's it. And then 4 screws, pop that board out. This is what it looks like. And then you just, don't have to rewire everything, the whole unit. Just change that board out and rehook those 4 little wires, and you're good to go.
So it has a separate replacement part number for that board.
Yes.
Excellent.
And so how the unit protects inverter systems, because like I say, typically you have this line voltage coming off the disconnect, and it's going to go right into the L1 and L2 on the mini split equipment. So by putting this thing in between and setting those parameters, now this contactor can open and cut power to that inverter system. So it's really brilliant technology. This is endorsed by Mitsubishi, by Fujitsu. Bosch loves this thing. All the vans that they have their equipment mounted in, every one of those you'll see an ICM 493 mounted in there.
Yeah, I've been pitching this for a couple of years. Once I had my first introduction to them, and I'm telling you, as a TSA, it was an equipment saver. I recommend them for every inverter installation.
Yeah, and particularly where they have historically, faulty power.
Yeah, if you're in a rural location, it was almost a requirement of mine to have a 493 on it.
So great product. We recently have had a person testing this with the charging stations.
Yeah, you mentioned that, like for the Tesla and the EV charging stations, which makes a lot of sense, because now we're just going to work on smoothing out the power and protecting the charging for that vehicle. I love the idea.
Yeah, and it's been working really, really well. So all the test results are great, and could open up whole new markets for us.
Absolutely.
Probably more in the electrical world, but for people in their homes and stuff too. My neighbor just a couple doors down has a Tesla and had all the electrical stuff hooked up in his garage and everything. And I asked him about that. Are you worried about any kind of fire or anything? Because I've seen those videos of the electric car batteries catching on fire. And that kind of, it's fire and mayhem. It's some bad stuff. So, we might find some new ways to utilize this, but for now, really, really awesome product for inverter systems.
Definitely.
True RMS, calibration to true RMS is super important, because inverter systems can be kind of persnickety.
They're pretty particular. Yeah. Anyone's worked on them understands that.
Yep. So you've got your low voltage range, your high voltage range, not to exceed 253. You can set the parameters on this thing. You can calibrate it with your meter.
Yeah, with the true RMS meter.
Your true RMS meter, and then that way you're definitely more accurate on the monitoring of the system. So let's see what else. I think we're just going to recap a little bit.
Okay. And if anybody has any questions, this is a really good time to hop into the chat box, and we'll see if we can't answer some for you.
Yep. So just recapping on line monitors, They provide a line of protection from voltage swings that can damage equipment. They constantly monitor incoming power, break the control circuit, preventing equipment to start up. There are single-phase and three-phase versions available. And again, a line monitor is not a surge protector. The surges are such a rapid event that they can sneak past that line monitor. They can't even damage the line monitor. So having both, and anytime someone's installing that ICM 450, they should be putting the appropriate three-phase surge protector.
Separate surge protector. So the primary option for surge plus monitor is the 493.
Yeah, well, yes, but that's single phase.
Yes, correct.
Right. So and they are working on a three-phase version of that, because there's a lot of VRF equipment out there.
Yeah, that'd be an ideal VRF control.
Yeah. So a surge protection device, which again is not a line monitor. Line monitors will protect you from both over and under voltage conditions. Surge protection is just going to offer protection for a spike event, but it prevents damage to the equipment and line monitors from events such as surges, lightning strikes, spikes, and dip. No, I shouldn't have said and dips on the line there. I got used to saying that. I apologize for that. That's a misprint. They only protect from spikes, not from dips. They utilize the thermally protected metal oxide varistors, which are self-sacrificing, absorb that spike, and can get used up and need to be replaced. But we've got LEDs on there that tell you that.
Sure.
The combination line monitor and surge protection device, like the 493, allows setting of parameters for over/under voltage with the built-in surge suppression on the board. It's really the only way to take an inverter system offline. It's the only animal of its kind out there. So really, really effective device, and one of our flagship items by far. So how about some questions? I know there's some folks out there that have to have a few questions.
Yeah, absolutely. If anyone has any questions, I guess I have a couple while we're waiting for anything to come through. So looking at the lineup, the only device that has a serviceable or a replaceable MOV is the 493 single phase.
That's correct.
Excellent. Okay.
Yep. The rest of them, you just toss the unit. And
it's a disposable component.
It wouldn't be cost effective to make those boards and things replaceable.
Sure, especially on some of those like 4A, NEMA 4A installations that are completely sealed and they're part of the actual circuit board.
Right.
Okay. So as a recap, a lot of things changing in the industry. A lot more inverters coming to our lineup of equipment from our manufacturers. We need to be very aware of the voltage that we are applying to our systems, both our incoming voltage for the structure and our voltage that is being utilized on the piece of equipment, to make sure that we are within specifications for our new equipment. Our line monitors, we can set our voltages, our minimum and our maximum, based on the voltage rating of the piece of equipment. And line monitors are separate from surge protectors, so they need to be verified if we have a component that has both or if it is just one of each. So yeah, a lot of great stuff. I haven't seen any other questions come in. Anybody have any opportunities for a chat with Keith Clark while we're here before we wrap the show up?
How can I become a master HVACR technician? There are, and I'm sure you can speak to this, but there are many really, really excellent trade schools and training facilities around the country. Isaiah, where do you live?
And I would say that, Isaiah, this is a good opportunity if you want to do some follow-up with me afterwards. My email is cbeck@escogroup.org. And I will point you into the direction of technician certifications. Okay, any other questions on line monitors and surge protectors and ways to protect inverter technology? All right, well, Keith, we sure appreciate it. Anybody wants to spend some time with Keith, he will be at the HVACR Educators Conference, March 20th through the 22nd, 2023 in Las Vegas, and we'll be doing a class for us there as well. And Keith, we look forward to seeing you there. Everyone have a fantastic rest of your evening, and we'll see you next week on Did You Know? The ESCO HVAC Show.
Thank you.
Thank you for joining Did You Know? The ESCO HVAC Show. You want to see some of these great presenters in person? Well, then we'll see you at the National HVACR Educators Conference, where many of these guests will be presenting live classrooms, and you'll have a chance to interact with them. Would you like to watch this show again? Hey, no problem. Just head on over to YouTube to ESCO Institute. Do you have a topic that needs clarified about some kind of a change in the industry? Well, then let me know. See Beck at escogroup.org, and we'll see what we can come up with.